Welcome back to Math in the Bubble with Mr. Daly. This is episode 3, and today we're going to attack non-linear simultaneous equations, which sounds complicated, but it's really not too much more than what we're already doing with regular simultaneous equations, just setting two equations equal to each other and solving for x values, and then solving for y values. So to start us off, I just wanted to think about if we had this line, y equals 2x minus 3, and we had this parabola, y equals x squared minus 3x minus 4, then how do we find the intersection points for those two graphs? Well, one way is to type those equations into Desmos, and that'll show you pretty much directly where your points are going to intersect. But I want you to understand how to do this without Desmos. How will we calculate this just on pen and paper? So, well, with regular simultaneous equations, when we've got equations that are set equal to y, then we can simply set the equations equal to one another. So if we set 1 equal to 2, then we end up with 2x minus 3 equals x squared minus 3x minus 4. And we can't do a lot with this at this stage, but we know we're going to have to solve a quadratic at some point because we've got an x squared term. And to solve a quadratic, we want to rearrange it so that our formula looks ax squared plus bx plus c equals 0. When we've got it like this, then we can put our values for a, b, and c into our quadratic formula. Right? So first step that we need to do is move our terms around so that they're all on the one side. So we're going to take that 2x and that minus 3, put it on the other side. So if we take 2x and put it the other side, it's going to be a negative 2x. So that will make negative 5x. And negative 3 is going to be a positive 3. So we're going to end up with negative 1 as our quadratic. And right away you can see that there's no real factors of negative 1 that are going to easily add to minus 5. So we're going to have to use the quadratic formula at this stage. Sometimes you don't. You get nice numbers and you get nice whole numbers as your answers, but not on this occasion. So we remember there's an invisible 1 there. That'll be our a. So for our quadratic formula, a is going to be 1. B is going to be negative 5, and C is going to also be negative 1. Put some commas in there. Okay. So x is going to equal minus b plus or minus the square root of b squared minus 4ac, and then all of that gets divided by 2 times a. So one thing I just wanted to note, you guys to note, is this bit underneath the square root. So that bit is called the discriminant. And when, so say we went back to our graph, if we know that there's going to be a solution to this one because we've got intersection points here. So we're going to have a positive value as our discriminant. But some lines do not actually intersect with the parabola. So an example of that might be y equals 2x minus 10. Oh, not 10, 13. So in this case, the line doesn't ever cross through the parabola because the parabola zooms up and then they're constantly going away from each other after this being the closest point down here. So if that happens, you won't be able to solve any points for x. And that's because you'll still have a quadratic, but you'll get a negative value in your so this will be negative if 0 solution. Also, interestingly, the bit that's highlighted will equal 0 if it's a tangent. Anyway, I don't want to go too much more off on a tangent. So there's different things. So usually I will actually solve that discriminant outside. So this is the discriminant. Just so that I know that my roots are going to be positive. So b squared is negative 5 squared. Also, you know, it's just easier to compress later. Minus 4 times 1 times negative 1. So we get 25, and then we got negative 4 times negative 1 is going to give us positive 4. So we got 29 now underneath our bracket. So x equals negative b will be positive 5 plus or minus the square root of 29. So that's our discriminant. Divided by 2 times a, which is just 1, so divided by 2. And if we put this into our calculator, it's very easy to get the two solutions because you just change your, if you write the whole thing out, you just change your plus for a minus. So 5, and I like to put a bracket around there because I'm going to divide the whole thing by 2. And sometimes your calculator will not do that automatically. 5 plus square root 29 close bracket divided by 2. That got me 5.193, just 4 significant figures, and if I make that a minus, and we've got negative 0.1926. Okay. Now, those are our x coordinates. We still need to get our y coordinates for our intersection points. So, to do that, you can use the parabola from the start, but it's easier to just use the line. The line intersects through both those points, so it's much more simple to use the line equation to find your so let's just call this x1 and this is x2. So our y1 will be 2 times x1, which is 5.193 minus 3, and our y2 will be 2 times negative 0.1926 minus 3. Just quickly do those. 5.193 minus 3. 7.386, and this one is 2 times negative 0.1926. Negative 3.3852. So we get two intersection points, one at 5.193 and 7.386, and then our second one is at those two. And that should be what we had on our Desmos graph, hopefully, if I didn't make any mistakes. Looks like I did it okay. Yeah. Right. Okay, so that's how you can find intersection points of a line and a parabola. So we're going to just focus on lines and parabolas, but there's other graphs that we can find as intersection points, but we'll do that later. All right. So I'll get you guys to do this exercise. Page 67, or actually 67 and 66. Now, if I was to do a rough sketch, we've got a negative x squared, so I'm just going to do a rough one. Negative x squared finishes down, so this is a negative x squared, goes through the origin, and x plus 3 goes through the point 3, and will be a generally flat graph. So right off the bat, by just drawing it, you can sort of guess that it won't have a solution because it's not going to pass through any points on the parabola. But let's just check it anyway. So if we set, let's make this equation 1, this is equation 2, 1 equal to 2, negative x squared equals x plus 3. If I bring that negative x squared to the other side, we're going to get 0 equals x squared plus x plus 3. Okay. the part C of question 2 asks you to explain why the graphs don't intersect. Well, one way to explain it with algebra is to use the discriminant. So if we work out the discriminant equals b squared minus 4ac, well, let's see. So a is going to be 1, b is also going to be 1, and c is going to be 3. So let's sub in those values. Discriminant equals 1 squared minus 4 times 1 times 3. So 1 minus 12 is going to be negative 11. So discriminant is less than 0. Therefore, lines do not intersect. Yeah. Okay. I think this one should intersect. So we'll try this one. This one's an easy one. And it's probably going to not require the quadratic formula. So let's not even draw it this time. Let's just set 1 equal to 2. Equation 1, equation 2, set them equal to each other. What we got? X squared equals 2x plus 63. Alright, I like to keep the x squared positive. It just ends up being easier for you in the long run. So I'm going to move those two terms across to the other side. X squared minus 2x minus 63 all equals 0. Alright, what are some factors of 63? We've got 6 and 9, 7 and 9 will give us a difference of 2. So we're going to be able to directly factorize this. So we've got negative 9 times 7 equals negative 63. Is that one condition? And negative 9 plus 7 equals negative 2, which is our C. So B. So we're going to get x minus 9, x plus 7, 0, which means that for this bracket to be 0, that x needs to be x equals 9 as a solution, and for the other bracket to be 0, x equals minus 7 as a solution. Seeing as we've got nice whole numbers, we can we didn't have to use the quadratic formula, so we saved ourselves a bit of time, and we can find if we got x equals 9 into 2, we can find the y value. So y equals 2 times 9 plus 63. So that's going to get us 18 plus 63 is 81. And then our other value, so we'll call that x1. So we just worked out y1. y2 is going to be 2 times negative 7 plus 63. So 63 minus 14 gets us 49. So we get 2 points. Intersection 1 is going to be at 981, and intersection 2 is going to be at negative 749. Alright, let's just plot this on Desmos to see if it actually did turn out that way. So when you're doing these sort of problems, it's always good to just have Desmos in the background, so you can just play with those formulas. So what do we have? We had just a straight x squared term, and we also had 2x plus 63. Alright, well, we're going to have to zoom out to find this. There we have 1 point, negative 749, that's what we calculated. And 981, another point. Okay, that's that one done. I might just select a more complicated one where we would have to use the quadratic formula to solve. I think number 18. So we're going to do question 18 from page 67. Y equals 3x squared and y equals, that's a complicated one. We've got 14x minus y minus 8 equals 0. Okay, so this time we can't just set the two equations equal to each other. Well, we could if we rearranged the second one for y, but we may as well just do a direct substitution. So this is what y is, so let's just put it in there and then do a bit of rearranging from there. So let's call this 1, 2, so 1 into 2, we're going to get 14x minus 3x squared minus 8 equals 0. Alright, I'm going to swap everything to the other side just so it eliminates the negatives and we have a positive on our x squared term. And then also I'm going to put them in the right order because we've got them completely out of order. Okay, so 0 equals 3x, so everything is going to swap its sign, so this has become a positive now. Then we have a negative 14x, and then we have a positive 8. Alright. Now we could use the splitting method, and I think that would probably work. But let's just use the quadratic formula to get ourselves some practice. So a equals 3, b equals negative 14, c equals 8. We'll do our discriminant first, so that's going to be minus 14 squared. I'll write the formula. It's kind of just being lazy. B squared minus 4ac. So negative 14 minus 4, a is 3, and c is 8. Minus 14 squared would be 196 minus 12 times 8 is that is 96. Right. Yeah. So that's going to give us a discriminant of 100, which is a nice number because that's when we do the square root of that. Um, minus b plus or minus the square root of the discriminant over 2a. Right. 14, so it's positive 14 because b was negative 14, so we got double negative cancelling out, plus or minus square root of 100 divided by 6. So x1 is going to equal 14 plus 100 is 24, divided by 6 is 4, and then 14 minus 10 is going to give us a secondary one of 4 over 6, or 2/3. Okay, now we can get our y values by putting them back into the, well, let's put them into that first equation. Y equals 3x squared. So you don't always have to do the line. Sometimes the x squared could be the easier one to substitute into. So y1 is going to be 3 times 4 squared. So 4 squared is 16. 16 times 3 is 48. Y 3 times 2/3. So subbing in this value. That's going to be 4/9. So 4/9 times 3 will be 12/9, which is the same as 4. So our two values were 4/48 and 2/3 4/3. Okay, I might just stop there, and if you guys have any questions from me, post them in the chat. Otherwise, that exercise that's your exercise there, and I'll post that on Schoology as well. I might just do that now. That's posted what we did. And has anyone given me the whole not intersecting section again. Yeah, let's do that. So this equation here we have a line and a parabola that aren't actually ever going to meet, and there's a way to sometimes you get more complicated equations that you can't actually draw, but you might want to know whether they're going to intersect or not. And the way to know that is using the discriminant. So if I should write some good notes on this. Basically, discriminant is b squared minus 4ac. So it's the bit underneath discriminant under the square root. That's a terrible square root. So there's three things that could happen. First thing, the discriminant is a positive number. When this is the case, there are two solutions to the quadratic formula, right? And there's a special case when the quadratic formula is equal to 0. I might just write 0 because it looks like an O is equal to 0. And that's when you've got one solution. So the excellence questions for this and for one of the internals require you to generally find a tangent. So a tangent, so this is like a tangent is when there's a line that's gone and it's just oh, that's a terrible drawing. So there's a parabola and there's a line and it's just touched in one place, right? So that's when the discriminant equals 0. So that's that case. The other, you could get another case where you've got an upside down one, and you'd get two solutions. So it doesn't matter whether it's a negative x squared. It's whether the discriminant works out to be positive or not. So that's and then the third case is when it's a negative number. So if you think about a discriminant, I mean a square root, you can't, if you put the square root of -1 into your calculator, you're going to get a math error. And that's because that's a number that doesn't exist. That's actually year 13 calculus. That's dealing with complex numbers in the imaginary plane. So really what we say, there's no real solutions. There might be imaginary solutions. But you guys don't need to worry about that till now. Just know that if there's a negative number, then then what it looks like on the graph is likely to be a parabola like this and a line shooting past and never intersecting with the graph. Yeah, so it doesn't matter whether the x's, so if it's both the x's is less than 0, it won't intersect. Oh no, it might. Okay. Hopefully that explained that, Helen. Good question. Great question. I didn't really actually go fully into it because one of the excellence questions is when you're given a line and you don't know, you might have y equals x squared is one graph, so that gives you your parabola, and then your other one is y equals kx plus minus 3. So that would be, there's minus 3 there, so you've got to figure out what the k value would be to make a tangent with the graph. So that's an excellence type question that we will hopefully be better to do those in class.